Right now, we're going to do the fifth point here on exponential. Now we do exponential equations. There's another formula that I need to add on top of the formula that we learned. I'll write the formula here. Note that a to the power of m equal to a to the power of n. This is an equation because you have an equal sign between the terms like this. This implies that m equal n. Or similarly, if you have like a to the m equal to b to the m, this implies that a equal b. Okay, so now let's start with question 1. 2 to the x equal 1. This is an equation because we need to find now the value of x. We need to say that x equal to something. Now, how do you do that? We'll do you know, there's a law of exponent that says any number raised to the power of 0 equal to 1. So we can apply this law that says a to the power of 0 equal 1 if we say that x is just equal to 0. Okay, if x is equal to 0, then to the power of 0 equal 1. We can say this implies that x equal to 0. Or we can also say 2 to the x equal to, instead of saying 1 equal 1, we can write 1 differently. We say a to the power of 0 equal to 1. So we can write, instead of writing 1, we can write 2 to the power of 0 because 2 to the power of 0 is just 1. Okay, then we can apply this law. Okay, we'll say this implies that x equal to something formula. This implies that x equal to 0. Okay, over here we just drop the basis, we equate the exponents. Okay, same in question 2, which is 3 to the power of x equal to 3 to the power of x equal to 3. When you don't see any exponent, understand that the power is just 1. Over here, we have some basis. What we do when we have some basis within the equation, we just drop the basis and then we equate the exponent. So the answer is that x is equal to 1. Okay, so x is equal to 1. Question 3. We can write question 3 there. 3 to the power of x equal to 27. So what we need to do here is to write 27 in terms of its prime factors. 27 is same as 3 to the power of 3 in terms of prime factors. If you're unsure, you can do the factor 3. 27 by 3, it's 9. By 3, it's 3. And then by 3, it's 1. Now we have like 3 times 3 times 3, which is 3 squared. Okay, or you can use a calculator. You write like 27, you press the equal button first, and then press shift, and then press this button here, effect, and then it tells us this is the prime factors of 27. So and then we have this form, the form that we had here. When the bases are equal like that, we just drop the base, we equate the exponent. So over here, we usually just drop this and then equate exponents. So you can just drop this, the basis, and then we're going to make x equal to, this will be x is equal to 3. Okay. Now let's take another question. So I'll leave question 4 for you to practice. Okay, you must do question 4. Now I'm gonna do question 5. Question 5 says 7 to the 4x equal to 49. So again, over here we need to convert 7. It's already a prime number, and then I'll leave it like 7 to the 4x, and then 49 will be converted into in terms of its prime factor, and 49 will be 7 squared. Okay, now this will be then 4x equal to 2. Now to get the value of x, we divide by 4. We divide by 4 both sides, because this will be simplified, and then we will have x will be equal to a half. Okay. And then we can do question 6. 3 times 3 to the x equal to 243. So question 6, 3 times 3 to the x equal to 243. So situation like this, we can either get rid of this 3, okay, or we can apply, okay, let's do this the two different ways. One way is like we divide by 3 both sides. So 3 times 3 to the x equal to 243. One way is like we get rid of this 3, we divide by 3, we divide by 3. And then this will be 3 to the power of x. This will be 3 to the power of x equal to 81. And then we can convert that into 3 to the power of 4. That makes x is equal to 4 according to the law we listed. Or we can apply the law of exponents over here, and then saying, you note that there is an invisible power of 1. So same basis, we can just write 1, 3, and then we add the exponent. So it's going to be like 1 plus x there at the exponent, and then equal to 243. Now we can write 243 in terms of its prime factors. If you do that in a calculator, you will get 3 to the power of 5. Then some basis like this, we can just drop the basis and then equate the exponent 1 plus x equal 5. If we move the 1 over, we'll get x is equal to 4. Okay. So I will leave question 7 also. I'll leave few questions here for you to practice. 7, 8, yes, out. So I will do. Let's move on to question 9. Question 9. The question says 3 to the 2 open x plus 1. No, x minus 1. Close brackets equal to 81. Now, we can write also 81 in terms of its prime factors, you know. Let's times here. Over here, we will do 2 times x and then 2 times -1 there. And then that makes 2 to the 2x, 3 to the 2x minus 2 equal to 81 is 3 to the power 4. Okay. And then this will be, in this case, we can just drop the basis. Okay. So the bases are common, we can drop the basis, and then this will be 2x minus 2 equal 4. And then that makes 2x is equal to 6. And then x will be equal to 3. Okay. Now, we're going to do another question. Let's say question 11 here. I'll leave 10 also for you to practice, which is 2 times 3 to the x equal to 162. So over here, if you try to write 162 in terms of a prime factor, look what will happen. 162 equal shift and then fact. We got something like that. Okay. Then what we can do in this case, we get rid of the 2. I'll divide here by 2. I'll divide there also by 2. And then this will be 3 to the x equal to 81. Now, 3 to the x will be equal to 81 is the same as 3 to the power 4. Then this implies that x will be equal to 4. Okay. Let's move. We can also same way we can do question 12, and then let's do 13. 13, the question 13 is like 3 to the x equal to 1 over 9. Over here, we can apply this law of exponent that says a to the negative m. Okay, let a to the negative m equals to 1 over a to the m. Now remember that those laws are useful from left to right as well as from right to left. So in this case, we say 3 to the x will be equal to 1 over 9 is like 3 squared. Okay. And then we will say 3 to the x will be equal to 3 to the negative 2. Because the bases are common, we can just drop the bases and then equate the exponent that makes x is equal to negative 2. Okay. Same also, we can do question 14, question 15. Let's show the questions. The same way we did question 13, we will do question, the same way we did this, we can do 14, 15. Now I am going to do 16, okay? 16, what we have, a half to the power of x equal to 4, okay? So what does it mean? There are quite different ways of solving this. I can first work out the fraction. You know, a half can be written as, if I want to write everything in terms of the prime factor, a half can be written as 2 to the negative 1, and then 4 can be written as 2 squared, okay? Now, this is like, this is like 2 to the negative x equal to 2 to the 2. Now, in this case, we can just drop the bases and then equate the exponents. That makes negative x is equal to 2. That means x is equal to negative 2. You know, when you have like negative x is equal to 2, you can find the value of x by just timesing by negative 1 the whole thing. Or moving simply just move the negative sign over. That becomes x is equal to negative 2. Okay, this way you can do question 17, 18, and 19 because they are quite similar. Okay, let's do 19. 3 and the third to the power of x minus 1 equal to 1 over 3. So this, we just write 3, and then a third can be written as, in terms of its prime factor, it will be 3 to the power of negative 1, and then 3 to the power of a third also 3 to the negative 1, okay? Now this will be 3 multiplied by 3 to the, careful here, we're going to times the exponent here. We're going to do negative 1 times x minus 1. So this is going to be like a negative 1 times, I must do that in the bracket, okay, equals to 3 to the negative 1. Okay, now remember over here we have also an invisible exponent there. Now we can combine the terms on the left. That's going to be like 3, 1 minus 1 open bracket x minus 1 equal to 3 to the negative 1. Now over here we can just drop the bases, and then we will have like 1 minus 1 open bracket x minus 1 equal to negative 1. Equal to negative 1. If I move this one over, and then this will be, we will have left with negative 1 open bracket x minus 1 equal to negative 1 minus 1, and then negative 1 will make negative x. Negative x, negative 1 times negative 1 makes positive 1 equal to negative 2. Now, if I move also this positive 1 over, it becomes a negative 1 there, so it makes negative 1 minus 1. And then we have like negative x is equal to negative 3. And then that means x equal to positive 3. Okay? If negative x equal to negative 3, this means that we times the whole thing by negative, If I move the negative over, it will change the sign, so it becomes x is equal to 3. Okay. This way, we can also do question 20. Or maybe, I don't know, if here someone don't understand it, let me explain. It's like, I want to have a positive, let me do this over here. I have like negative x equal to negative 3. I want to have positive x. What I can do, I'll times here by negative 1. I'll times there also by negative 1. So it's like negative x equal to that. Now, negative 1 times negative x makes x, and negative 1 times negative 3 makes positive 3. So that was the answer. Question 20. Now let's here 20. Was like, it's like 1 over 8 multiplied by 2 to the 2x equal 1. So in a situation like this, we can write 1 over 8 in terms of 1 over 8 is like 8 to the negative 1, okay? Multiplied by 2 to the 2x equal to 1. So 8 to the negative 1 is like 8 is like 2 to the 3, and then this will become like 2 to the negative 3 multiplied by 2 to the 2x equal 1, and that makes like we're going to combine like terms because we have some bases here, you know. This will make like 2 equals to the power of 2x minus 3 equal to 1. Okay. Now, you know, this can be possible only if the exponent here, if this exponent is just equal to 0. Okay. If it is 2 to the power of 0, it's going to be 1. Or we can also say, I'm saying that because of the law a to the power of 0 equal 1. So if we have like 1 here, it means 2x minus 3 equal to 0. Okay, it means 2x minus 3 equal to 0. And then that makes 2x equal to 3. And then we can write, if 2x is equal to 3, we can work out x when we divide by 2 and by 2 there. And then we get x equal to 3 over 2. Thank you. If you do like, this is your first time subscribing the channel, and then like the video. Thank you. Well, these are another series on solving the exponential equations. So let's start with question 1. Question 1 says 5 times 9 to the x minus 1 equal 5. Now, the only way to simplify this is like when we get rid of this 5, because it's a product. So I divide by 5, I divide by 5 there, and then we'll get like 9 to the x minus 1 equal to 1. Now, we did say it according to the law of exponents, or the definition, the corollary, any a to the power of 0 is equal to 1. So at the moment that we get this situation, okay, whatever it is equal to 1, so in this case, we're just gonna say x minus 1 here is equal to 0, okay? Whenever we have this situation, we just wanna say the quickest way to solve this is like to equate that the exponent equal to 0, and then that makes x is equal to 1. And then question, which is very similar to question 2. I think I'll leave question 2 for, okay, let's just do question 2. Question 2, we have like 7 times 49 x plus 2. You're welcome. Equal to 49. Okay, in this case, we will we can divide by 7, or we can write, I prefer to divide by 7, it's going to be much quicker. Simplify here by 7 by 7. And then this will be 49x plus 2 equal to 7. And that makes 49 will be 7 squared. Okay. And then 49 in terms of its prime factor. And then 7 here is like to raise to the power of 1. Now what we can do is we're going to do 7 to the power of 2, open bracket x plus 2. Be careful here, it's very important. Usually students will say 2x plus 2, but no, it's 2 open bracket x plus 2, okay, equal to 7 to the power of 1. So over here, because the bases are common, we can just drop the base, okay, and then we will equate the exponents. Now this is how we do 2 times x and then 2 times 2. That makes 2x plus 4 equal to 1. Now this will make 2x equal to 1 minus 4. That makes 2x equal to -3. And then x will be, okay, if 2x is equal to -3, then to get x, we will divide by 2 and then by 2 there, and then we get x is equal to -3 over 2. So so yeah, that was question 2. A similar way we'll do the same way we'll do question 4. Okay, over here, okay, let's first do question 3. 1 over 49 to the power of x, 1 over 49 to the power of x equal to 343. So again, we can transform this. Okay, apply that law of exponent that says a to the negative m equal to 1 over a to the m. As I said, the formulas are useful both as well as from left to right or right to left. So in this case, we can write we can write 49x. No, let's first write 1 over 49 is 7 squared. It is 7 squared, and then 343 is 7 raised to the power of 3. Okay, you can check that in the calculator. If you do 343 equal shift and then fact, see, it's 7 to the power of 3. So this will be then it would then make 1 over 7 to x equal to 7 to the power of 3, and then this will be 7 to the power of 2 negative 2x, okay, according to this law. And then this equal to 7 to the power of 3. Now that the bases are common, we can just drop the base and then equate the exponent. That makes 2x equal negative 2x equal to 3, and that makes to get the value of x, we'll divide by -2. We divide also by -2, and that makes x equal to -3 over 2. That was question 3. So the way we did question 3, I will leave you to practice to do question 4. Okay, over here you can divide by 5, or you can reduce. Maybe we can read. Let's just do question 4. Let's do question 4. Question 4 will be 5 multiplied by 125 x plus 3 equal to 1 over 25. So we can divide by 5, okay? we can divide by 5 here, we divide by 5, and then divide by 5 is like times by 5 at the denominator. It's the same thing, okay? Dividing by 5 both sides. Here in the fraction, it's like times by 5 at the denominator. That's divided by 5. This will be like 1 to 5 to the x plus 3 equal to 1 over 125. Now, because it is 125 there, I don't need to write them in terms of the prime factor again. I can, but I don't need to. So I leave it like that, 125 to the x plus 3. And then over there, I will apply the formula, the property that says 125 to the negative 1, okay? Now that the bases are common, then you can just drop this basis and then equate the exponent. So x plus 3 will be equal to negative 1. So if I move the 3 over, and then x will be equal to x will be equal to negative 1 minus 3. So x will be equal to negative 4. Okay, and then do question 5. What does question 5 says? Let's see. Question 5 over here. Okay, we can 2 over 3 to the power of x minus 2 equal to 8 over 27. So we can reduce this, okay? But one of the best way, we can write, one of the way of doing this is like, if it is 2 to the power 3, x minus 2 will be equal to, note that 8 is like 2 to the 3, okay? And then 27 is like 3 to the 3, okay? If I write them in terms of the prime factors. Now, the fact that the power are common, we can write it with a common exponent, okay? It's gonna be like 2 over 3, okay, all to the power of 3, okay? Remember the law of exponent says like a to the m over b to the m is the same thing as a over b to the m. So I don't need to continue to simplify this because the bases are already common. You can just drop those bases and then see x minus 2 equal to 3. And then if you move the negative 2 over, it becomes like 3 plus 2. And then x will be equal to 5. Okay. We can also do question 6 that involves decimal 0.25 to the power of x equal to 0, just say comma 125. Okay, so this we can transform this. Okay, 0.25 is like saying 25 over 100 to the power of x, and 0.125 is like in a fraction. You can see that this is a quarter. Okay, it is like a quarter. And then this is also like 1 over 8. But in case you don't see it this immediately as I do, you can first write like that, 125 over 1000. Okay. And then simplify. If you simplify, you get a quarter to the power of x equal to 1 over 8. Okay. And then in the fractional form, if I write them in exponential form, 4 is like 2 squared. So it's going to be like that. And then 8 is like 2 to the power of 3 under 1 there. And then that will make 2 to the negative 2. If you apply this law of exponent, I'm going to write it somewhere. Let's write it here. A to the m, negative m equal to 1 over a to the m. So it's going to be like 2 to the negative 2m equal to, that was x. Sorry. to the power of x, and that was x there, equal to 2 to the negative 3. That makes 2 to the negative 2x equal to 2 to the negative 3. So the bases are common, we can just drop the bases, and then we have like negative 2x equal to negative 3. Now, to get the value of x, we divide by negative 2, and then x will be equal to positive 3 over 2. Okay? So, the same way we did question 6, this is what you can do, how we will do question 7, 8, and we can do now question 9. I think okay, let's do question 9. Question 9 says it was 3 to the power of 3x, no, 3 to the x plus 1, all to the power of 3 equal to 9 to the power of x minus 3. I guess it's gonna be easy by now. This can be transformed. You know, over here we will just times exponents. According to the law, that says a to the m, like that, to the power of n equal to a to the m times n. Okay, so we can write here 3 to the 3x plus 1 equal to 9 can be written in terms of its prime factor. 9 is like 3 squared, and then x minus 3. So this makes like 3 to the 3x plus 1 equal to 3 2x minus 3. Now the bases are common, we can just drop the bases, and then that makes like over here we do this times that, this times that, this times that, and this times that, and that makes 3x plus 3 equal to 2x minus 6. Now we can move 2x over and then 3 over. That makes what? 3x minus 2x equal to negative 6 minus 3. Now let's just split this way, and that makes x equal to negative 9. Okay. Then I will leave question 10 and 11 out, so we can do question 12. Question 10, I mean 12. 12, question 12 is 0.5 to the power of x minus 1 equal to 4 to the negative x. So in this case, 0.5 can be, we can transform this. This is like a quarter, I mean a half, okay? So this is like a half to the x minus 1 equal to 4 can be written as 2 squared, okay? To the negative x. And then a half also, a half can be written as 2 to the negative 1. And then over here, we can just times the exponent, okay? So this will be 2 to the power of x plus 1 equal to 2 to the negative 2x. So there, we can just drop the bases, and then we have like x plus 1 equal to negative 2x. Then we can just move negative 2 over, and then 1 over, and then this will be what? X plus 2x equal to negative 1. That makes 3x equal to negative 1. And then we can divide both sides by 3, by 3 there, and then that makes x is equal to negative x will be negative 1 over 3, okay? That was question 12. We can also do, so I think by now we can leave the rest of the question. 13, 14, and 15 for you. Okay, I'll leave those questions for them. Question 13, 14, and 15. Okay, for you to practice. So thank you. If you like